so I wanted to go over what the notes that we took today in class, as well as add some notes to them for tonight. So we started with the objective of defining congruence and determining correspondence. So we said two figures are congruent if and only if they can be mapped onto one another using rigid motions. Then what we did is we defined what a rigid motion was, what congruent meant, what corresponding meant, what a congruent statement means. Then we looked at an example of a congruent statement where triangle ABC is congruent to triangle DEF. And we said from that congruent statement that we can say 12 other things from just that congruent statement. That the sides that correspond, AB and DE, are going to be congruent. BC and EF will be congruent. AC and DF will also be incongruent. Not only that, but the angles A and D will be congruent, B and E will be congruent, and F and C will be incongruent because they correspond to each other in the same order on here. We looked at another thing where we said, given that these sides are all congruent, let's write our congruent statement. And what we did is we said that AB is congruent to YZ, so AB and YZ have to go first, and then C corresponds to X, so C goes last. And then we turn the page, and we had a new objective. And it said, determine the criteria that makes two triangles congruent. So we'd start talking about included sides and included angles. And pretty much included sides are just the side between two angles. And the included angle is just the angle in between two sides. So that's where we left off. And where I want to pick up is I want to be talking about congruence criteria. So congruence criteria, we're going to want to start out by making a little table on the bottom half of our page here. So I'm going to make a little table. You know what? We have that nice little chart made. Let's start filling it in. So I'm going to be looking at the minimum amount of information I need about two triangles to say whether or not they are congruent. So my congruence criteria, I'm going to be referring to A as angle and S as side. So the first congruence criteria that we're going to look at is called side, 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 meaning that we have three pairs of congruent sides. So between two triangles, okay, we have one pair of congruent sides, two pairs of congruent sides, three pairs of congruent sides. And based on our definition of congruence, that two things are congruent if they can be mapped on to one another, this would be congruent because each side length maps onto another side length that is congruent. Yes, that is enough. The next congruence criteria is angle, angle, angle. So this is saying if we have two triangles whose angles are all congruent. So, and this actually does not work because what we can do is we can shrink or expand the triangles, make them smaller or bigger, without changing the angle measure. And so this side right here isn't going to map onto this side because it's much longer than the other one, even though the angles are the same. So this is not enough, no. Angle, angle does not, angle, angle, angle does not work, okay? The next criteria we'll look at is side, side, angle. And this is where the angle is not included between the two sides. So if I had to look at a picture of this, side, side, angle. Okay. And the reason why this does not work is because, let me grab my compass and show you real quick. Where's my compass? There it So if I were to draw a picture of this, okay, and I'm going to make a triangle. So I'm just drawing you the picture. You don't have to actually do this. Okay. The side length, x, y, and angle measure z. And now I'm going to make, so length y, angle measure z. I'm going to make a third side that is the same length. I'm going to make two different triangles using that third length. So because I'm using a radius, okay, I can effectively make two triangles using this radius. I can make the triangle over here, and I can make the triangle over here. So triangle number 1 could be like this. Get that better. Could be like that. And triangle number 2 could be out here. And I'll outline them both so you can see them. Okay? So the first triangle is this shape right here. And it has x, side y, side z. And the second triangle is this shape right here. And this length over here is also x, because I used it as the radius of that circle that I drew. So these two triangles, the blue triangle and the brown triangle, have a pair of sides that are equal, one side that are x and another side that's y, in an angle. So there's side, side, angle. But they're two different triangles, so they're not congruent. So side, side, angle does not work to prove congruence. Well, what other combinations of sides and angles can we have? We can have side, angle, side. And what that looks like is now the angle's included between the two sides. So one pair of sides is congruent, the angle between the sides is congruent, and the side on the other side is congruent. So these two triangles, this is enough to prove congruence. Angle, side, angle is another variation on this. So what this means is that I'll have two angles that are congruent, and then another pair of angles that are congruent, and then the side in between them will be congruent, and that's enough information to prove congruence. And then the last one is side, angle, angle. And this is also actually enough to prove congruence. So side, angle, angle will be enough too to prove congruence. And there's one extra special one. It's called hypotenuse leg, and it only works for right triangles. And tomorrow I want you to think about why hypotenuse leg works to prove triangles congruent. It has something to do with the Pythagorean theorem. So our congruence criteria that work to prove triangles congruent are side, 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 angle, side, angle, side, angle, side, angle, angle, and hypotenuse leg. Okay? These congruence criteria are the minimum amount of information we need to show that two triangles are congruent.